Okay, this is the P4 paper from June 2023. Question number 3, and this is going to be, first part is partial fractions, and then we're going to be integrating partial fractions, which normally gives me logs, and then finally doing some work involving log rules for 3 parts of the question. Let's start with part A then, which says, can I take 8x minus 5 over, let's copy it out while I'm talking, 8x minus 5 over 2x minus 1, 4x minus 3, and can I turn that into a partial fraction? Absolutely we can. A over 2x minus 1 plus b over 4x minus 3. You guys should be absolutely hot as you can on these questions. Just make sure you show all your working out nice and clearly. Don't want to make any mistakes here. It will cost us huge marks later on. So this right-hand side here, if I'm going to be getting a common denominator, I'm going to do that times that times that, and then the bottom 2 times together. So I'm going to get a lots of 4x minus 3 plus b lots of 2x minus 1 all over 2x minus 1, 4x minus 3. So that's the same as the left-hand side. Just tidied it up using the iPad. And then what I'm going to do is I'm going to just equate the numerators. So just tell the examiner I'm doing that. It takes 5 seconds to do that. Equate the numerators here means that I can say 8x minus 5 must be the same as a 4x minus 3 plus b 2x minus 1. And at this stage then, what I can do is, in order to get rid of a or in order to get rid of b, I want to make that equal to 0 or that equal to 0 by my choice of x. So I'm going to choose x equals 3/4 first. If I choose x equals 3/4, I get 8 lots of 3/4 minus 5 is equal to a and then 0, that was the whole point, plus b 2 lots of 3/4 minus 1, and you can tidy that up. We're going to get that b works out to be equal to 2 if you do that. Similarly, let's choose x equals a half. Then I'll get 8 lots of a half minus 5 is equal to a 4 lots of a half minus 3, and b, well this time that'll work out to be equal to 0, and that leads me to a working out to be equal to 1. Do the calculation yourself. So I've split that successfully into partial fractions. 8x minus 5 all divided by 2x minus 1, 4x minus 3. That fraction now can also be written as 1 over 2x minus 1 plus 2 over 4x minus 3. So part A sorted out. Part B then, can we now find the integral of fx? Yes, I can. Let's just show what we're going to do. We're going to say, okay, so for part B, the integral of 8x minus 5 all over 2x minus 1, 4x minus 3, that can be written down as the integral of the 2 partial fractions of 1 over 2x minus 1 plus 2 over 4x minus 3 dx. Okay, now we've just got to integrate the right-hand side. At this stage of you going through and integrating, I'm hoping you're not going to have any problem integrating these two relatively straightforward terms. If I've got 1 over x, the integral of that is going to give me log 2x minus 1, put it as a modulus because that's the correct way of doing it. So it'd be log 2x minus 1. Because I've got this 2 in here, that means I'm going to have half log 2x minus 1. When I'm doing the other one, well, I've got the 2, so that stays where it is. I've got log 4x minus 3, and then again, because of this 4 here, it means I'm going to be dividing by 4, so I end up with that plus my constant. You could leave it like that or just tidy it up to whichever level. Well, you wouldn't leave it as 2 over 4. That's the only thing you wouldn't do. I'm going to leave it as half log 2x minus 1 plus half log 4x minus 3. Now, I might normally tidy that up further, but I can see with part C I'm going to need to do all my log rule work anyway, so there's no point in doing that too early. I think that's perfectly acceptable as the answer for part B. Part C, if we go and look at it, then says, right, okay, if you integrate this between 3k and k, they're giving me the answer of half log 20, and they're asking me to work out what k is going to be. Right, so it's going to take a little bit of algebra and certainly some log rules. So we're saying the integral between 3k and k of fx dx is going to be equal to a half log 20. So in other words, sticking 3k and k into my integral over the other side. So half log 2x minus 1 plus a half log 4x minus 3. We don't need the constant of integration now because we're doing that between 3k and k, and that's going to work out to be a half log 20. So this thing on the left-hand side here, I need to make that into a nice, easier single log. So what I'm going to do before I do any calculating is I'm going to say that's a half log and then 2x minus 1 4x minus 3. Okay, if you've got log of A plus log of B here, that can become log of AB, and the half I'm just taking out as a factor there. So if I now do that between 3k and k, and again, really at any stage I want to, I could take the half out if I want. So if I take this half out here, actually I'm going to do it right now and put it there, then what I can do is cancel that half with the half log 20 just to make things slightly easier. So we're going to say log 2x minus 1, 4x minus 3 between 3k and k is the same as log 20. So if I put 3k in, I'm going to get log 3. 3k is going to give me 6k minus 1, isn't it? So 6k minus 1, and 3k is going to give me 12k minus 3, minus log, and then putting k in, is going to give me 2k minus 1, sorry, handwriting, 4k minus 3. So that is going to be equal to log 20. Now again, using my log rules, I've got log of A minus B here, so I can say that log of, 6k minus 1, 12k minus 3, all over 2k minus 1, 4k minus 3, that is equal to log 20. So now we can E both sides, or basically just get rid of the logs here. I'm going to have 6k minus 1, 12k minus 3, all over 2k minus 1, 4k minus 3 is equal to 20, and now this is going to turn into a quadratic. It could be that there's things there that I can cancel. I can't see anything that cancels out there. What happens if I take 3 out? No, I'll still be left with 4k minus 1 there. There's nothing that factorizes, so you may as well just multiply everything out and see what we get. So I've already done that. On the top, I would get 72k squared minus 30k plus 3 all over, on the bottom, I get 8k squared minus 10k plus 3 is equal to 20. This is just algebra now, so just getting this all sorted out. We're going to get 72k squared minus 30k plus 3 is equal to 160k squared minus 200k plus 60 here. That tidies up to, just do it down here, 88k squared minus 170k plus 57 equals 0. Now at this stage, they might expect you to try and be able to factorize. You could use a quadratic formula, only because I've done it for a while. I've already done it previously. I can say that that actually does factorize to 2k minus 3 44k minus 19 equals 0, which is going to give me k equals 3 over 2, or k equals 19 over 44. And then going back to the question, find the value of k for which this works. So we're only taking the log of k equals 3 over 2. If you do 19 over 44, you'll actually get a negative when you're doing the other part of the question. So we have to take log equaling to, the k equaling to 3 over 2. Right, a lot of algebra in that, a lot of complicated stuff in there for a question 3, but hopefully that all makes sense to you.